All right. So I do have other coworkers as part of the talk who I'd like to acknowledge. Jim Smith, my supervisor, Jeannie Patton, Randy Swati, and Sarah Hagan. We all work on what we call the Nature Conservancy's LANDFIRE team. All right, so today I'd like to talk about our fire regime products. First of all, what I'm referring to when I refer to that product suite, how we created them, how they've changed over time, and then how they're being used by our user community. So first of all, we'll dig into what I mean when I refer to this product group, and they're really the layers that characterize the fire frequency and severity, as well as a suite of products shown on the bottom that characterize vegetation conditions. And most of these I think are fairly intuitive. When you look at the name, you know what mean fire return interval is, and so that gets mapped out on the landscape. But I'm going to show you a couple of maps because maps are what LANDFIRE does largely, and they sort of illustrate these concepts better than I can describe them. So one of the major maps in this suite is our fire regime group map, and it's a combination of the frequency and severity in 5 classes under the reference condition. So it's a pre-settlement estimation of what we think the fire regime was like across the country. Another map in this suite that not everybody is as familiar with is our succession class map, and this is a map of current conditions. What it describes is the vegetation state on the landscape. So you can see this diagram in the upper left there. It's kind of a hypothetical construct of how vegetation grows over time. So LANDFIRE models that and describes each of these successional stages for every biophysical setting that we map, and those states are assigned a letter to represent them, A through E. And those are mapped on our succession class map, and so what you see in kind of the orangey brown is what we call succession class A. Now that varies what succession class A means from type to type, but by and large that represents an early cirral stage on the landscape. Likewise, in the dark blue, the succession class E typically represents a late cirral vegetation state on the landscape. And then of course, there's the vegetation condition class layer. Now, this was previously referred to as the fire regime condition class layer, but what it's actually showing and what it actually measures is a change in vegetation structure and composition from the reference period to the current as represented by that succession class map that I just showed. And because that's really what it's measuring is the difference in the vegetation, we're now calling it vegetation condition class. That's a much better descriptor. So don't be confused. It is part of the fire regime condition class metric, because fire regime condition class has 2 components, departure in fire regime and departure in vegetation. So it is part of FRCC, but it's only the vegetation component. Okay, really briefly, I'll go over how we create these products, and I'll give you a little disclaimer up front. I'm not a map maker, I'm a map user. So we have lots of map makers in the room, though, so if you have a lot of technical questions, you can ask them too. We start with our biophysical settings map. That's one of the potential vegetation concepts that LANDFIRE maps, and vegetation models, which I'm going to talk about vegetation models later on this afternoon, but those are models of what we believe reference conditions were like. And so to map the historical fire regimes and the fire regime groups, we simply line up every biophysical setting on the landscape with its vegetation model, which is used to model that reference fire frequency and severity. So then succession class is mapped a little bit differently because of course that's supposed to represent the current vegetation on the landscape. So we do that by combining several of our vegetation layers. We take existing vegetation type, height, and cover. We look at that combination of vegetation within each biophysical setting, and we take a rule set developed from the vegetation models to map succession class. And then the fire regime condition class, which I just said we changed the name, but it's an old diagram, so it should be vegetation condition class, is mapped using that succession class map to represent the current condition, our vegetation models where we generate the reference condition, and then that's applied for every biophysical setting on the landscape, and that's how we get our vegetation condition class. Okay, these products have changed over time, and those changes have important implications for how you might apply these data. And so I want to go over some of those changes. The first 3 rows here deal with vegetation condition class, and then the last one affects all of the products in this suite. So first of all, in LANDFIRE National, our first iteration, we just mapped vegetation condition class for the lower 48. We've since started mapping it for the whole U.S. As I've already mentioned, we changed our terminology to better represent what we're mapping. And then another important change is we changed the vegetation condition class summary unit. First, in LANDFIRE National, we were using ecological subsections. That's a coarser scale, larger summary unit. And now we're using hydrologic unit codes, which is a smaller watershed level. And for those of you who are familiar with the calculation for fire regime condition class and vegetation condition class, you know that the answer you get can vary with your spatial summary unit. It's a scale-dependent metric, so that's a pretty important change. Finally, we have altered our reference conditions a little bit. In LANDFIRE National, we use the vegetation models, but we put in another layer of modeling with the landscape succession model. And we did that to get more spatial variability in our reference conditions. So that's how it was done originally, but that's a very time-consuming and resource-intensive process. So for that and other reasons, we changed how we're deriving reference conditions, and we've gone back to just using our original reference condition vegetation dynamics models. With a slight tweak, they were grouped, and I'm going to talk a little bit more about that in some subsequent slides because it's a little bit complicated, but it's very important for how some of the subsequent products were produced. And then to complicate things further, for our 2010 product, we're going back to our original vegetation model suite. So my main point on this slide is that there have been changes in the methods over time, and so users need to be aware of that and be cautious if you're comparing 2 different versions of our fire regime products that were made with different methods. It might be hard to tease out real changes on the ground versus changes in methods. Okay, so talking about group models here isn't ideal because I haven't already talked about what the models are, but it's an important factor in some of these map products. So I am going to dive into it a little bit here. So originally we created a fairly large suite of reference condition models, and so for example, in an area you might get several variations of a ponderosa pine model. And in some places it was more variation than was needed, and so there was an effort to simplify these by choosing just one model to represent this group. And so in this case, they would choose this particular model, and its reference conditions were used to represent what was previously 3 different variants of the same thing. So it's like coarsening the resolution of the biophysical settings. But remember that those reference conditions and the frequency and severity that comes out of these models is used to map all of these other things. And so what we found is that in some cases that grouping was really effective and it eliminated some unnecessary variation, but in other cases we eliminated really important regional variation, and the product some of the products in certain places have suffered because of that, and that's why we're going back to our original suite of biophysical settings models for the next iteration of LANDFIRE. Okay, so how have the models been applied? And I always like to show an application because this is where the rubber meets the road. It's not just about how we create these maps, it's really about what the user community does with them. So I'm going to show you some work here by a friend and colleague of mine, Chris Singer, with the Nature Conservancy of Oregon, and some of the folks that he works there with, Darren Borges and Mark Stein. And they've developed a method for estimating treatment needs across a really broad area And they're using some LANDFIRE data to do that. Specifically, they're using our succession class map and our reference condition models. And so what they're looking at is estimating a treatment or restoration need for all of the forests in Oregon that are in frequent fire systems, so in fire regime group 1. And so if you look across the state of Oregon at the different successional stages, you find that under the reference condition, the majority of the landscape was in the open states. No surprise. And if you look today, you'll see that there's a lot more closed condition on the landscape than there was historically. And so in their analysis, what they're looking at is where is the surplus of late acres that might be shifted to have more open condition on the landscape similar to our reference condition. And they call those the surplus acres. So they're just looking at these surplus acres where you can shift closed states to more open states to match the reference condition. And I think it's important to say here, it's not just about matching this mythical reference condition that we want to get back to. It's about creating forests that we think are more resilient going forward and maybe creating some jobs in the woods along the way. So in their analysis, this is really the result. These are the frequent fire forests. You can see shaded in from yellow to brown with the darker colors representing areas where you have more of those surplus acres in the closed state that could be shifted to a more open state, and a forest that is probably more resilient to changes in climate as we move forward. And I think their final estimate of the restoration or treatment need would be somewhere around 4.8. Is that right, Chris? Okay. So Chris is back here, and if you're interested in this work, it's ongoing work. He's still working out the methods, and I'm sure he'd be happy to talk to you about it. Our colleague up in Washington State, Ryan Haugo, is also doing something very similar using LANDFIRE successional class data and looking at treatment needs, but he has a slightly different approach. So there's some really interesting work going on there with some of these fire regime layers. Couple of take-home messages. These products, I think, are really unique, especially because we produce them at the national scale, and they're very useful for framing and addressing fire questions at broad scales. They're also useful at finer scales, but if you want to apply them on finer scales, we strongly encourage you to review and modify them as needed to represent your local landscape. And because we know that they're useful at smaller scales, and we're encouraging people to go through and review that data, we've developed some materials to help you do that. We have some user guides for reviewing and modifying spatial data that you can link to on our website. And I think, as has already been mentioned, there are a couple of teams on LANDFIRE that specifically are chartered to help support users. So you can use us as a resource. So in conclusion, you can get fire regime product information and great maps at landfire.gov, the mothership. Also, we have the data distribution site where if you're interested in the raw grid data, you can go and get that there for free. So I'll leave this up, and I'd be happy to take any questions.